All right, let's go with this next example here. I'm finding the interval of convergence and radiance of convergence for this here power series, and more often than not it's the ratio test that that we do use here. So do need to look at the limit n goes to infinity of the a plus n plus 1 term divided by a sub n terms. So what is that here in this case? Well, I'm seeing it's going to be n plus 1 times x plus 3 to the n plus 1 divided by 5 to the n plus 1. That's a to the n plus 1. But divide that by a sub n, which is that, so that's going to be times the reciprocal. So this is what I have to work with. This looks pretty long, but I think some nice things happen. N plus 1, break this out because I'm going to be able to cancel, right? It'll be x plus 3 to the n times x plus 3 to the 1. This will be 5 to the n times 5 to the 1. Yeah, so some nice things are going to happen here, aren't they? 5 to the n's cancel, x plus 3 to the n's cancel, and so if I split out, let's go with the n's. And the 5 here. Go ahead and put the 5 here. And the x plus 3 over here. Did you get everything? All right, so this, as n goes to infinity, probably want to look at dividing that by n, right? So that would be 1 plus 1 over n divided by 5 times the x plus 3. So that's going to go to 1/5 x plus 3. Which you can pull out the 1/5 there out of the absolute values. All right, and so the ratio test says, hey, that's absolutely convergent if it's less than 1. If 1/5 x plus 3 absolute value is less than 1, ratio test tells me that's definitely absolutely convergent. Well, to get that in terms of just x, solve for the x here, that's going to be multiplied by 5. So its absolute value of x plus 3 is less than 5. Which means if I trap that between positive 5 and negative 5, then I can go ahead and solve it all the way for x, if you will. Just subtract the 3. And so I have negative 8 is less than x is less than 2. Which is, therefore, basically the interval. What the only thing is, if it's greater than 1, it's divergent. That's what the ratio test tells me. However, if that equals 1, the ratio test does not tell me what it does. So I have to do where it equals 1. So what that amounts to is I also check the endpoints then. So I don't know about the equal to 8 and the equal to 2. I know everything else, but I just don't know that. So let's come back over here and check our endpoints. So at x equals 8, negative 8, what do we got? Well, let's see what series we got. N equals 1 to infinity. N, and so negative 8 is my x. So I'll wind up with n, the series n equals 1 to infinity, n times negative 5 to the n divided by 5 to the n. Well, obviously, I've got some canceling there. However, it's 5 to the n and negative 5 to the n, so what does that come out to be? Yeah, we can split that up. Think n times negative 1 to the n times 5 to the n. And so I'll end up with just n times negative 1 to the n, which we haven't encountered before, but on lectures, anyway. Let's look at that. All right, so n equals 1. So the first term, let's just look at it term by term. 1 times negative 1. So it would be negative 1. The second term would be 2. Negative 1 squared, so it would be positive 2. Third term would be 3. Times negative 1 would be negative 3. 4, negative 4. 6. You get the idea. Which you've got some up and down there, but good way to think of it is look at these two terms. That's 1. The next two, that's 1. The next two, that's 1. And so if you think about it, that's going to be infinitely many 1s. And if I add infinitely many 1s, is that going to give me a certain number? That's infinity. This diverges. Whoops, that one diverges. So at this endpoint, we've got divergent. What about the other endpoint? Well, the other endpoint, we've got 2, so at x equals 2, we'll have what series? N equals 1 to infinity, n, so x is 2, so we have 2 plus 3 to the n, over 5 to the n. Hey, that's just series of n times 5 to the n over 5 to the n. Of course, 5 to the n's cancel, so it's just the series n equals 1 to infinity of n, which is 1 plus 2 plus 3 plus 4. What's that going to do? That's just going to keep getting bigger and bigger and bigger, so that's going to be divergent too. So x equals 2 is divergent, x equals negative 8 it's divergent, so that was it. That was our interval. The interval of convergence is just negative 8, strictly less than x, strictly less than 2. Didn't have an endpoint to add to that. Now, radius of convergence. Talked about this a little bit. The radius of convergent, again, if you think of it as a number line here, you got negative 8 to positive 2. And so the radius, that's just talking about how far from a center point do I go. Well, in this case, however you want to think about this, it's 10 units long there, or whatever. The center here would be 3, wouldn't it? I mean, not 3. Negative 1, huh? Center would be negative 3, yeah. That's what I meant. But however you need to look at it, this is the radius. From that center, that is my radius, r. Well, in this case, it turns out to be, we said 5. It's 10 units, so divided by 2. But I would point out here that this does exactly match when I got the absolute value by itself, got rid of the 1/5. That matches up with that. So you might make a note of that too. If you get it to this form right here, that, yeah, we've got the absolute value of x plus or minus something, or just absolute value of x, your radius is going to turn out to be that. So anyway, so the radius of convergence is 5. And I was noticing in the back, they do, aren't they writing the interval in interval notation? So it'd be -8, comma 2, and the radius of convergence is 5. Okay. That one up. Okay, let me do this one now. Change that one. Let's do that. All right, yeah, let's look at this one. It's a really fun looking here. N equals 0 to infinity, -1 to the n, x to the 2n over 2n, 2 to the 2n. N factorial squared. Okay, so my limit as n goes to infinity of the an plus 1 over an, absolute value, will be what? It'll be the limit n goes to infinity -1 n plus 1 x to the 2 times n plus 1 over 2 times 2 n plus 1 n plus 1 factorial squared. That's just a n plus 1, a sub n plus 1. Then I divide that by a sub n, which is going to be just a reciprocal of this right here, right? This will be 2 to the 2n n factorial squared, -1 to the n, x to the 2n. Okay. Now, with this being in absolute values, does the alternating sign part really do anything? No. Everything is going to be a positive, no matter what that is. Okay. Well, let's see, this right here will be x to the 2n plus 2, or in other words, x to the 2n times x squared. And that'll be basically the same. It'll be x 2 to the 2n plus 2. That'll be, n plus 1 factorial is n plus 1 times n factorial, so I got that squared. All right, so this will be 2 to the 2n plus 2. So that'll be 2 to the 2n times 2 to the 2. Yeah, we've got some canceling going to happen here. X to the 2n's, cancel. 2 to the 2n's, cancel. What else? Well, this being n plus, I'm not going to write the whole thing over again. That'll be that squared and that squared, right? So that is going to cancel out there. So what do I have? Limit n goes to infinity of x squared over 4 times n plus 1 squared. Okay, well, let's split that out. I don't know, how much do you need me to show you here? I mean, if you multiply that out, you get that. But what about this right here? 1 divided by, I mean, say it's 1 divided by, if I divide that by n squared, zero, isn't it? Okay. Yeah. This term's going to 0. So I have 0 times x squared. Yeah. What is that telling me? Well, this limit, no matter what x is 0, which is always less than 1. Because it's 0. Well, what does that tell me? It's not dependent on x at all being less than 1. Because before, we got something like the absolute value of x was less than 1. So that depended on something upon x. Here it doesn't depend on x at all. It's always less than 1 because it's 0 times whatever x is. If x is 1,000, if x is 10,000, if x is negative 1,000, it's still 0, which is less than 1. This one's convergent for all x. Except, let's think about it. Except, well, is there anything not for which this would not be converted? Oh, no, okay. I'm thinking something else. Sorry. No exception. Okay. For all x. I was thinking the other way. We've got convergence. Everywhere. There's nowhere. It's not convergent. So how do we write that? Well, the interval of convergence then would be for all x, so that would be negative infinity to positive infinity. And then the radius of convergent r, well, negative infinity plus positive infinity divided by 2. Yeah, would be infinite radius of convergence 2. All right, is that okay? All right, so that could happen. Yeah, if you get this limit going to 0, you've got convergence everywhere. All right. Here's another one. Find the interval of convergence, radius convergence for this one. N equals 1 to infinity. N factorial, x minus 2 to the n. Okay, well, let's look at our limit. A sub n plus 1 divided by a sub n. All right, so that's the limit. N goes to infinity. Oh, we got n plus 1 factorial times x minus 2 n plus 1. And since this one doesn't have fractions, I'm just going to go ahead and divide. Don't have to do the reciprocal thing here. Just divide by a sub n factorial, x minus 2 to the n. We'll do our same tricks here. N plus 1 factorial is n plus 1 times n factorial. X minus 2 to the n plus 1 is x minus 2 to the n times x minus 2 to the 1. What happens? Well, some nice things cancel. X minus 2 to the n's cancel. The n's factorials cancel, so I'll wind up with the limit as n goes to infinity. N plus 1 times x minus 2. What's going to happen to that as n goes to infinity? Oh, specifically, what's going to happen to that? That's going to go to infinity. Infinity plus 1. Yeah, this is infinity. Okay. Now, by ratio test, remember, this is just the limit on my ratio test. Remember, the limit on the ratio test, if the limit is less than 1, it absolutely converges. If the limit is greater than 1, it diverges. That's greater than 1, isn't it? This limit is always greater than 1, except. Okay, so that's where I had my exception. I got too quick on my exception. So limit diverges for all x, except, let's think about one little thing here. So we're saying the limit diverges for all x, except there is one, which it does not. Except for x equals 2. And here is why. If x equals 2, we're going all the way back to the original series here. If x equals 2, that series becomes what? It becomes the series n equals 1 to infinity, n factorial, times 0 to the n, which is n factorial times 0, which is the series of zeros. Does that converge? Yeah, because it doesn't do anything. I mean, it's not a very interesting series, but that series is equal to 0, so it does definitely converge. When we say it converges, that means it goes to a number. That series definitely goes to a number, okay? So, what is the interval of convergence here? Well, it diverges everywhere except 2. It's not an interval. It's kind of a misnomer there. The interval of convergence, it just converges at one number, 2. So we'll just say, usually, I think the book will note it, 2 with in the set braces. It's just convergent at one number, 2. The radius of convergence. What's the center of this thing? 2. The center is 2, and it goes nowhere on either side, so that's not much of a radius, is it? The radius would be 0. You were going to say 2? No, 2 would mean we'd go out 2 units that way and 2 units that way. We don't go anywhere. Okay. All right. So that's, now you have, you wish you'd known that before, huh? Yeah, so now you have some ammunition on Section 8 there.